Assalamualaikum warahmatullahi wabarakatuh. Thank you very much to Mrs. Okkie and Mr. Dwi, who has been the supervisor of our internship program while in Pusteksat 8. Previously, we want to convey the result of our activities during work from home. We complete the project that we made named Making Mikrostrip Antennas and complete the internship program report. Here, we will present the result of our internship program in Pusteksat for approximately 3 months. Thank you and keep watching.
My name is Praba Vananda and my student number is 121-017-1038.
My name is Silvione Seroy and my student number is 1210-171056.
My name is Rizkya Rahmandhita. My MRP number is 12101711060.
About the company, Pusteksat have some focus. For more information, you can visit the website.
Prima project succeeded in making and launching the following to Kartika series rocket telemetry in 1964 on November 27, 1963. The Institute of Aviation and was from National Space 8. This is the structure organization of Pusteksat 8.
Division at 8 is Deputy Aviation and Space Technology, focused on satellite and antenna. Daily of us is learning about radar, satellite, and design of antenna microstrip. The effect frequency is different from ISAR, is SAR inverse that use of each frequency. There are differences in objects that can be detected.
SAR is one of the satellite payload, while ISAR is used on land. The kind of antenna that we used for this project is microstrip antenna. To design this antenna, we have to know the basic calculation first. There are patch width and patch length, with the formula shown in the display. It was the basic calculation. For another design like pinset fit or kind of slots, just adjust to the antenna designed. This antenna has operating frequency at 1.27 GHz, 2.3 GHz, and 5.3 GHz, with return loss less than minus 10 dB, VSWR less than 2, gain more than 3 dBi, and has linear polarization. Because we are using FR4 as a substrate, we have to know the specifications of that substrate too. The specifications shown at the second table.
Design of Mikrostrip antenna, frequency 1.27 GHz. The parameter used is for HS is 1.6 mm, HT is 0.03 mm, W is 54.88 mm, and WA is 3.11 mm. This is the design of square patch microstrip antenna with single element, frequency 1.27 after having side iteration. On picture number 2 is work frequency value and return loss of design of microstrip antenna for frequency 1.27 GHz, and picture number 3 is work frequency value and VSWR of design of microstrip antenna for 1.27 GHz. And picture number 4 is frequency gain value of 1.27 GHz. And the next picture is initial arrangement of twice two frequency array antennas of 1.27 GHz after experiencing the patch side length and distance between patch. Picture number 1 is work frequency value and return loss of antenna twice to frequency 1.27 GHz. Picture number 2 is work frequency value and VSWR of antenna twice to frequency 1.27 27 GHz, and picture number 3 is antenna gain value twice to frequency 1.27 GHz. And the last picture is antenna gain value twice to frequency 1.27 GHz. And this is the direct measurement result for antenna array twice to frequency 1.27 GHz.
So this time, I'm going to present about the design of microstrip antenna at 2.3 GHz frequency. The table that displayed on the screen was the parameter that I used to design the antenna. I was using an array method that called 1x4 array, which means in a line there are 4 patch layers. The purpose of using insert fit is to match the fit line with the 50 ohm impedance at the patch. After the design was finished, I got to simulate the design. From the simulation result, it can be seen that the operating frequency was at 2.314 GHz with the point of VSWR at 1.1 and the value of the return loss at minus 25.46 dB. It can be concluded that the design of the antenna was good to have that result. The next one is the simulation result for gain and directivity. From the picture, it's shown that the result of the gain is 7.58 dB and the directivity is 11.82 dBi. From the simulation results above, I can continue to fabricate the antenna on FR4 substrate. Then there's direct measurement results at 2.3 GHz frequency. The antenna that was fabricated will be tested on vector network analyzer and the chamber room. So the left picture is the result on vector network analyzer and the right one is the result on chamber room.
For my project, I designed a microstrip antenna at frequency 5.3 GHz. I chose this frequency to check the substrate material from FR4 because FR4 is not recommended for high frequency. After doing some calculate, I found the parameter to design the antenna microstrip on TST Studio site. This is the parameter to design antenna microstrip at frequency 5.3 GHz. This is the design of antenna array at frequency 5.3 GHz with array 1 across 4. It is linear. After I design the antenna and start the simulation, we can see the result of S11 parameter or return loss at frequency 5.3 GHz. It is around minus 18. And then VSWR result for the simulation at frequency 5.3 GHz, it's around 1.2. It is good because VSWR is good if it's under 1.5. This is the result of directivity simulation at frequency 5.3 GHz. And the gain simulation result at frequency 5.3 GHz about 7 dB. This is the direct measurement result at chamber room Pusteksat for frequency 5.3 GHz.
This is the end of the presentation, and there are some photos of activity reports. Thank you for the attention and knowledge given by Mrs. and Mr. We are apologize if there are errors in our behavior and words. Thank you for watching this video presentation. Wassalamualaikum warahmatullahi wabarakatuh.